Hello, everyone. Welcome. Delighted to see a large number of you have joined already. Expecting around 50 to 60 people, I think. Just while we're waiting for the last few to join, I'd just like to do a little bit of an introduction, personal, and to the Contamination Control Network. So my name is Gordon Farquharson, and I can see lots of friends have already logged in. So welcome, and nice to see old friends and new friends joining this webinar. I'm a chartered engineer by profession and have been involved in cleanroom technology in various ways for nigh on 40 years. And I'm currently the president of the Contamination Control Network and have been highly involved in standardization and chair the UK's British Standards Institution LBI 30 committee. I'm also chair of the SEN Technical Committee 243 in the same subject area, and have recently represented the UK as head of delegation to ISO Technical Committee 209, more of which you'll hear later. The Contamination Control Network was formed around 18 months ago, and it's a UK-based members not-for-profit society with membership from all around the world. Its mission is to provide news, knowledge, training, education, and a network for personal partnering, collaboration, and communication. Its focus is cleanrooms and associated controlled environments, and this can, of course, cover a broad range of interests, from clean rooms on the human scale to isolators, barriers, and cabinet devices, including design, control, testing, and operation of all these systems. Some current Contamination Control Network resources include a member copy of Clean Air and Containment Review 4 times a year, and recent published guidance has included revision of ISO 14644 parts 1 and 2 from 2015, information about this process, background and explanation of EN 1822 and ISO 29463 on HEPA and ULPA filtration standards, energy saving practice in BSEN ISO 14644 part 16, which was based on a preceding standard that was produced and published by British Standards Institution. And CCN is active in training in the cleanroom arena, particularly delivering the CTCBI cleanroom testing course. And the most recent edition of this was delivered earlier in March this year. And there is another course planned for November this year. So a broad range of resources and services. Today, during the webinar, which is about to start, please ensure you're muted. I suggest you turn off the video if you have a constrained internet connection. Please use the chat for any questions. And of course, we hope that you find this event informative and helpful. And my mission is to help you understand, first of all, that there are 18 current EN ISO cleanroom standards, and many people are unaware of this, and more importantly, how to apply these in the real world. I'll just wait a couple of minutes and then I will commence. Good, it's time to begin. So welcome everyone to this Contamination Control Network webinar. And our subject for an hour or so this afternoon concerns the EN-ISO family of cleanroom standards, their application to projects. So this is delivery of a cleanroom project, or it could be a clean air device procurement, and to cleanroom operations. So I call this a route map, and hopefully at the end you will understand the range of standards that have been published in this family, and it should help you pick the right ones for your project or your application. And en route, I will explain a number of important features of the standards, including, for example, how they are produced to have international credence and credibility, and to recognize that these standards are routinely revised and updated, and you need to keep your finger on the pulse to make sure you're working to a current standard. My name is Gordon Farquharson. I'm a chartered engineer by profession, president of the Contamination Control Network, and have been involved in standardization at BSI and internationally since the early 70s. So I'm going to work through, hopefully in an organized and structured way, the around 18 standards that form the suite or family of EN-ISO cleanroom standards. So the presentation has been prepared to enable you to obtain a timely update of the current standards. So very, very important to understand that every EN-ISO standard, once it's been published, has to be considered by the community, that's the user community in CEN and ISO, every 5 years for revision. So it could well be that an existing standard you have is rendered out of date by a revision. And very, very important, therefore, to make sure you are using a current standard. Like everything in this world, technology moves on, best practice evolves and changes, and this is reflected in the periodic revision of these standards. If you are hunting for key words that are important to this program, clean rooms, clean air devices, ISO, CEN, BS, BSI, normative, informative, HEPA filter, commissioning, testing, certification, qualification, and so on, would all be found in some detail within these standards. The program is intended today for a broad range of professionals, whether you're involved in design, construction, supplying components, commissioning, startup, qualification, testing of cleanroom facilities within the life science sector, or any other industrial or technical sector or academia. There should be something in this presentation for you. And I just see there's a question here. So CCN will make this presentation material available after the event. So my agenda in the next few minutes today is to introduce you, if you're unaware, or update you on the family of International Cleanroom Standards. Now, here in the UK, these are published as BSEN ISO standards. And this means that they have gone through a rigorous international process, have been endorsed by various nations, and within the United Kingdom, the British Standards Institution is the publisher of these standards, and they go through a development and review process within a committee I chair in the British Standards Institution. So I would say, banging the drum somewhat, that the UK is highly involved in the evolution and application of these standards. So important questions for you. Are your standards up to date? Are you working to the current standard? I will make some links to industry sector guidance and regulations, and particularly the life science sector. So clearly within the cleanroom world, the life science sector, as well as deploying these standards, needs to comply with various industry regulations and guidance. So these links are important. I'll also show how links to other trade and professions and best practices, such as commissioning of engineered systems, can also relate very closely and in a supportive way to these standards. And I also want to help you understand the standards sufficiently to choose the right standards, whether it's in your life science project, your other cleanroom project, or in your operations. So a little bit about the standards environment. Now out there, and don't worry about the detail too much, but there are a number of important mechanisms that prevent ISO and CEN from having conflicting standards in the same subject area. So this is called the Vienna Agreement. And for these cleanroom standards, virtually all the work is led by ISO and has been carried out in the Vienna Agreement, and CEN, the Committee for European Normalization, parallel processes the same piece of work. So a document that's published as a EN ISO is an identical document. It just has two front covers. Nations parallel vote in CEN and ISO. So there's two slightly different voting systems, but they're voting on the same documents. And very importantly for the United Kingdom, CEN is a European institution, not a European Union institution. So CEN continues exactly as it did previously, and the UK is a part of CEN. So there's no change to that core activity. EN standards must be published as national standards. So here in the UK, if an EN is published, it has to be published as a BSEN. And this really is one of the main reasons why the UK would be highly active in the development of standards that are published through this route. So virtually all the standards I'm talking about are published as BSEN ISOs, and one of them is published as a BSEN standard without the ISO element. Is my library up to date? Are my standards current? So I would ask you at the end of this to make sure that you are working to current standards. All these standards are generic. They apply to all industry sectors and all aspects, from design concept through to routine operation of the asset. They are not life science, they're not pharma standards, they are not application specific. They could apply to a packaging operation, which requires clean, controlled conditions. Could apply to a semiconductor wafer fabrication operation, making the microchip that drives the computer that you're watching this on. Could apply to a life science application in development, manufacturing of any dosage form, and could equally apply to specification of methods for testing, certification of performance of clean rooms and clean air devices. So generic standards covering a broad range of potential applications and many facets of specification, procurement, testing, and use of the assets. The family of cleanroom standards is evolving and continually evolving as a need is seen for international standardization in different aspects of cleanroom technology. And I want to go through this diagram, which I hope brings some clarity to the complex family of standards. And I divide these into vertical standards that largely define cleanliness attributes of clean rooms. And then horizontal standards that focus on design, testing, applications, and some specific clean air devices. So we'll go through these. And again, in this short program, I don't have time to go through the detail of every single standard, but I will highlight certain standards which are at important stages of development or revision, and make sure that you understand the essence of the subject area considered in each of the standards. So the core standard around which the whole sense of a clean room exists are ISO 14644 parts 1 and 2. So part 1 and 2 is classification of air cleanliness by particle number concentration. So it focuses on characterizing the cleanliness of a space by particle counting, particle number concentration, and it's this that enables me to call my space a clean room or a clean air device. So this is really the core. How I get there, how I design it, and what other aspects I test will be adjuncts to this fundamental classification. Just while I'm talking about the standards, be aware that these standards are evolving continuously, and sometimes we need to refer to the standard with a date annotation, usually after a colon, and sometimes we refer to it without a date, or regulatory instruments sometimes refer to the standards without a date. If the standard is referred to without a date, this means always it is the latest version. If it's referred to with a date, then it is the specific published version with that date. So that's an important point of semantic detail. Very often I see in documents comply with ISO 14644. Completely meaningless. So be a little bit fussy and picky, please, on your nomenclature when referring to the standards. We go next, and the numbers, hopefully you'll see in the logic of how I've grouped these. So we have a standard part 8, which is talking about air cleanliness by chemical species concentration. So there are certain industries that are worried about airborne molecular contaminants that might affect the product. So very largely in the semiconductor industry, the manufacture of semiconductor wafer devices can be poisoned by molecules of different chemical agents. They could be acids, bases, could be organics in the air. And therefore, those industries require the ability to specify cleanliness by air chemical species. Some industries require to classify clean surfaces by particle number concentration. So there are certain industries, I think particularly of some micromechanical, optical industries, that are really concerned about particles depositing on the surfaces of products in process. And so part 9 is a specification of surface particle cleanliness. And it talks about number and size of particles in a unit area on a surface. And it gives you a mechanism of defining the cleanliness attribute of surface particles. Part 10 goes back to the chemical cleanliness, and this now refers to surface chemical cleanliness. So again, an interest particularly of the semiconductor industry related to chemicals on surfaces and outgassing from materials in close contact to process or product. So part 10 is surface chemical cleanliness. Part 12 concerns nanoscale particles. So air cleanliness by nanoscale particles. Back in the past, we in 2001, ISO 14644 Part 1, 2001, had a specification for ultrafine particles. Now these have been removed from ISO 14644 Part 1, 2015, and now there's a separate standard that deals with these small tiny particles. So these are the sub 0.1 micron particles in the air, and the reason they're separated is because the measurement technology is quite different from the regular particle counter we would use for part 1. So this is air cleanliness by nanoscale particles. Then we move on to part 13, which is assessment of cleaning of critical surfaces in clean rooms. Now, this is not janitorial cleaning. It's not cleaning and disinfection that we might be familiar with in the life science sector. This is more related to precision cleaning, and it uses one of the cleanliness attributes methods I've already described. So part 9, for example, part 10, for example, a before and after test to determine the effectiveness of a cleaning process. So that's part 13. Pretty unusual. I haven't seen this used in the life science sector, for example. So it's understanding these standards and knowing when to use them that's important. Part 14 is a relatively new standard, and that's equipment suitability by airborne particles. So this enables a vendor of a piece of equipment to characterize the piece of equipment to identify suitability to put into your clean room. So if I wanted to buy a particular instrument, or a good example I was looking at recently was a rapid rise roller type door for a clean room application, I can find increasing number of vendors who've had this kind of equipment certified in accordance with this standard, so that a purchaser can be confident that it isn't a source of unwanted contamination in the space. So part 14, equipment suitability by particles. And then there is a brother or sister to this, which is equipment suitability by chemical species outgassing, which again would correlate to a semiconductor industry need and requirement. There are 2 ISO standards in a different family, ISO 14698 parts 1 and 2, that specify various aspects of biocontamination control. You might call that microbial cleanliness as well. They do not define classes, but they define various aspects of developing a monitoring program collecting the data and evaluating it. Now, you need to be a little careful at the moment because there is an EN in the same subject area that in CEN member countries, including the UK, has replaced the ISO standard. And it is intended that ISO will take on board and develop the EN 17141 as an EN ISO standard. And one of our attendees today, I noticed Conor Murray from Ireland, is the convener of the working group that will be leading that process. So hello, Conor, good afternoon to you. And if anyone wanted to talk about that process, then Conor Murray in Ireland is the person to speak to. So those are the vertical standards going through cleanliness attributes. Now we need to think about the horizontal ones. And these, of course, act in some way as glue, linking some aspects together. Part 3 is about testing. And now that focuses on testing all the cleanroom related attributes and parameters that are not associated with the cleanliness attribute. So parts 1 that I talked about, 8, 9 and 10 and 12 all specify a method of measuring the cleanliness attribute in the standard. And this part 3 standard addresses the other things like airflow, filter leak test, airflow uniformity, parallelism, and so on. So a whole range of tests that we need to carry out during commissioning and in the life science sector, qualification of cleanroom performance. So it's a shopping list of test methods. And it gives quite a lot of detail of those reference test methods and guidance on instrument specification to carry out those tests. Now, part 4, which I'll use quite a lot in the section on thinking through the application of these standards, covers design, construction and startup of cleanrooms. Now, this is currently in major revision. So I'll just explain a little bit about that evolution when we come to it. But it's a really important standard that takes you through a logical progression from concept and need through user requirement, design, building the installation, starting up and commissioning it, and going through verification and so on. You will find if you're in the life science sector, you would be able to fit all the Annex 15 qualification and validation principles into this standard. The good news is it doesn't even mention the word validation in it. So it's written in a way that can be applied in a flexible way to any procurement of a device or a more complex clean room. So part 4, very important standard. Part 5, which is in a process of revision, is clean room operations. And that specifies various aspects of clean room operations, from garment management through to training of individuals, personnel working in the facility, maintenance management, and so on. So a whole range of aspects related to clean room operations dealt with in part 5. And that is just about to start a systematic review process. Part 7 is a little bit strange, and it's called separative devices. And if you read the subtitle, it talks about isolators, glove boxes, and mini environments. So this addresses a number of areas of things which are not human scale clean rooms, and talks about aspects of the boundary of, say, an isolator system, leak testing, and various aspects of manipulations inside the enclosure. Again, this standard is due for its systematic review, and whilst the principles are clearly established, I think there will be particularly aspects on leak testing and some more pragmatic guidance that will be in a revised version. So part 7, separative devices. Part 16, which is one that the UK was heavily involved in, concerns cleanroom energy saving practice. Now, it's been written deliberately so it can be applied to a new asset or facility, or you could equally apply it to an energy saving upgrading project on an existing asset. And it starts at quite a high level, identifying concepts and principles that will inherently lead to low energy clean rooms, and then drills down into more detail about various techniques that might be deployed to achieve those objectives. And examples might be low friction filtration selection, sizing of equipment, variable duty fans, and so on. So some quite well-established principles and one or two challenging areas which you could use as a checklist during concept or detailed design to evaluate and challenge whether the design takes into account best energy saving practice. So part 16 is related to cleanroom energy saving and can be applied to a new asset or an existing asset that you want to revisit and improve the energy efficiency of. Part 17 is quite a new one and concerns particle deposition rate. So there are a number of industries that actually are not so concerned about tiny submicron particles floating around in the air. They're interested in the killer particles that land on the product or process. And this standard has been developed to provide guidance on the application of particle deposition rate monitoring in clean rooms. Now, I could see down the line in the future that this might become the electronic settle plate of the future. And there are a number of industries, particularly in small scale inkjet printing, for example, that are particularly concerned at defined particle sizes that will block the fluid pathway in an inkjet printer, certainly in a commercial inkjet printer. So particle deposition rate application, a relatively new standard that's been recently developed and published within this EN ISO family of standards. And then another standard that's in development is material suitability. So this relates to materials that you might bring into a clean room. So these could be single-use consumables or reused items. And again, it's perhaps a little bit more like a checklist and guidance on things to consider in the procurement of such materials. So I hope that's given you a flavour of the family, the vertical standards related to cleanliness attributes, and the horizontal standards related to aspects of design, testing, and devices. Maybe the extent of these was a bit of a surprise to some of you. So, 18 standards currently. I'm not going to talk through them again. I think I've described them in broad terms, but this is just a summary of all those standards that exist. And I'll just finish building that. So just a couple of highlights. The core foundation standards, ISO 14644 parts 1 and 2, 2015, hard to believe they're already 5 years old and are going through their systematic process. Right, so that systematic review has been launched and the results of that should be published. Whether the marketplace, you guys and gals, want to see a revision to this, or whether you're happy for it to continue for another 5 years. Cleanroom testing part 3 has recently been published. Part 4 is in a revision process, and actually it's going to come out for a draft international standard review, so that's in the public domain, fairly soon. So we call this DIS, Draft International Standard. Part 5, revision is due, but this is the current standard. Part 7, revision is due. There's a minor revision to Part 8, Part 9 and Part 10, but not substantive. It's mainly a terminology related thing. And the final one I just want to reiterate down the bottom here, the CEN EN 17141 from 2020, biocontamination control, is just about to start a process of evaluating to convert it into an ISO standard. But at the moment that is published as an EN 17141 2020. So that's the family. Probably a surprise to some, but not to all of you, I hope. So we now need to think about links to regulatory guidelines and how to use these standards. So I think there's a logical hierarchy here, the clean room context, you might call it. So a little pyramid. Starting at the top, we've got the product and or the process. So we've got critical attributes of the product, and we will have critical process parameters. And in the clean room sense, this will include air cleanliness, surface cleanliness, airborne particles, surface particles, microbial contamination, and so on. So the product or process always drives the requirement. Then in the life science sector, we have GMPs and mandated standards, and these tend to define performance requirements. They don't tell us how to get there. So this is why ISO standards are often referenced in regulatory instruments, because you need help to decide how to create, for example, a grade A, B, C, or D space to comply with GMPs in the life science sector. The GMP purely provides the performance requirements and doesn't really help you in the detail of how to get there and how to undertake testing to prove satisfactory performance. Then underneath the GMPs, the regulations, which in some countries are published as laws, we have guidance. And guidance is the industry-specific guidance where you get more detailed performance requirements. So in Annex 1, for example, and US FDA's aseptic processing guidance, you get much more explicit requirements for sterile products manufacture about air cleanliness, about room pressure differentials in clean rooms, and so on. Then we have the standards. So the technical standards, the EN ISO standards I've been talking about, which define various aspects of operational and test requirements. So in our GMPs, you will not find a single word about how to classify a clean room, but you find that in the ISO standards and ISO 14644 Part 1, without a date, is specifically referenced in those regulatory instruments. Therefore, it means always the latest version of that standard applies. So you need to be aware of that. Then we have the next layer down, which includes industry monographs. So here, particularly in the life science sector, where you see most of these in the public domain, industry associations produce guidelines on how to get there, much more detail, because particularly in the life science sector, the industry likes to feel the comfort that everyone is doing things in a similar way. We don't really want to be out on our own, blue sky thinking, whilst some regulator or auditor is looking over our shoulder, expecting us to conform to current practice. So industry monographs then fill in usually much further detail about best design, installation, and operational practices. And then finally, but please never diminish this, the fundamental underpinning is competent people. So good engineering practice, knowledge, expertise of the people who are trying to interpret all this and deliver all the things that are not written in the regulations, guidance, or standards. You will not find a single word in a GMP document or an ISO standard about commissioning and balancing of a clean room. That relies on good engineering practice. So please never forget that. So we move on to the next important part of our discussion today, which is thinking about how to apply these ISO cleanroom standards in a logical way to our world. That could be our project in development, our procurement, or our operation. Now, I'm going to use in this a framework strategy that you will find in ISO 14644 Part 4. Now, the current version of that includes a structure and guidance, and this is being enhanced and developed in a revised version, which is currently in progress, as I've already mentioned. And you'll see later on, because it has quite a nice diagram in it, I'm going to use the flowchart from the new Part 4 that takes us through a progression of logical practice within a clean room project, if you like. Both these current version and the version being finalized at the moment can be adapted to small and large projects. They can apply to new or refurbishment, and they are written in a flexible way that you can link them into GMP qualification and validation practices. So they don't conflict, but they provide some structure in a slightly more thorough way, going end to end in the process. So 2001, so you can see Part 4, 2001 is pretty old now, 20 years old, and it has this rather simplified diagram of the stages of a project from concept through to fully operational, going through various stages. And in here is included the concepts of qualification and validation, particularly in the healthcare sector, that are identified here. Now, in the revised version, that's refined somewhat and becomes a little bit more sophisticated and I think a bit better organized. So there's a flowchart diagram that starts off with the need and requirement, goes through defining the detailed requirements, URS, the design process, construction of the installation, startup, including commissioning and verifications, which you could read into our qualification activity, and then ultimately into operations and maintenance. And each of these normative sections, 5, 6, 7, 8, have associated informative annexes that provide more detail. So I'm going to use this diagram to actually think through how all our 18 standards might be applied to these different stages. So I'm going to use the revised version currently in development as a logical route map through the process. So I split this into two parts and we'll look and see which of our standards might apply during the various stages. And you'll see I've also added in a couple of links to some regulatory input so you understand how that might fit in. Okay, so the idea, this might be the business case, the objective, there might be some budget and timeline constraints that are defined, the business need. So we start off there. So there will be a real need, and that will be the basis of moving on to the next stage of defining requirements. Now, of course, we're just focusing here on the clean room or clean air device asset. The overall project will necessarily include procurement of equipment, revision of management systems and so on to ensure that that asset is effective and under control. So the GMPs are part of defining our needs. So whether that's coming out of Annex 1, UDRALEX Volume 4, or US FDA aseptic processing guidance, in here we find the fundamental requirements. It tells us at a very high level the cleanliness requirements in the space. So clearly that is where we get some of our user requirements from. The GMPs set certain specific compliance requirements, maybe related to flows, pressures, and so on within the clean room. So we need to take those into account. Then we need to employ, during this requirement stage, appropriate reference to the cleanliness attribute. And remember, that could come from parts 1, 8, 9, 10, or 12. All of those express cleanliness attributes in the clean room or clean air device. If it's a life science application, we're looking at part 1 for airborne particles. We might have another attribute of particle deposition rate. Right? So that's another attribute of cleanliness that we might add to the mix. So it might be that my particular process says that I'm really concerned about in my micromechanical, making my gyroscope or my optical system or my inkjet cartridge, particles depositing on the product or process. So I might introduce that as a specification attribute of my clean room. We then move on to the design process. Now, the design process in the document sets out 3 steps of the design. So concept, basic, and detailed. And it says, by the way, if it's a very simple device, you might combine all these steps. So be aware of that. There is some flexibility. This is not a mandatory, absolutely, you have to go through all these stages. There's quite a lot of flex within the concepts written in this document. The design might include application of part 7, separative devices. It may be that an isolator or some other barrier enclosure is the solution, and I have some technical detail requirements that are drawn from part 7. It might be leakage specifications of the enclosure. It might be pressure testing and so on. So that's likely to be a stage I might use part 7. Of course, during the design, part 4 applies. So part 4 goes through, as part of its methodology, because it's the document we're looking at, guidance on the design process. It also has guidance on the requirements process, what you should consider within the requirements. Consideration of energy would be an important part of the design process. So the checklist aspects of this, things to consider, may well be useful both for the designer, the professional designer, but also maybe the customer as well, as using it as a basis, as a benchmark, as a checklist for energy considerations. And you might decide that some of them are inappropriate. For example, this standard very clearly points out that variable air volume systems in clean rooms, whilst having a strong potential for energy reduction, also increase the complexity of the systems. And therefore, you must take this into account when deciding whether to invest in such energy-saving measures. So it's quite a balanced document from that perspective. Part 3 includes the testing. So I would say absolutely you have to consider how and ensure that the design is testable. One of the most common things is finding out that nobody thought about how to do the in situ leak test of the HEPA filters in the design phase, and there were no convenient injection points. And it turned into a nightmare during the startup and even more of a challenge to the user during the operational routine testing and certification of the clean room. So part 3 has a whole lot of elements that should be engrossed in the design. And then, of course, I'd also have GMP qualification aspects. So during the design, I'm going to involve verification through design qualification, for example, maybe at more than one stage in the design. And then finally, of course, good engineering practice and engineering standards. There's a whole raft of stuff that sits there as a core foundation to good design practice. Remember that within the ISO cleanroom standards, there isn't a single thing about checking the air conditioning calculations, other than identifying that they need to be reviewed and signed off. So very important not to lose sight of these things. No amount of certification and testing by air cleanliness, part 1, will actually approve whether or not the design was done in an efficient and effective way. So moving on to the next stage, the construction, startup and into operations, we can see a similar pattern of application. So part 4 has a big chunk in it related to construction. So ranging from clean construction protocol, I want it clean at the end, so I build it as clean as possible, rather than building dirty and then trying to clean it. So there's guidance on some elements of that practice, for example, and also on approving progressively the quality of the building of the installation. Part 3 starts to apply very specifically during the commissioning and startup process. So there's a whole range of testing that is specified in part 3 that would apply to various aspects of the clean room and various performance attributes of the clean room. Part 4 itself includes specific guidance on setting to work, verification, training and handover, so it applies to this section. But also don't forget that there's a whole lot of good engineering practice. So clean rooms inevitably have air treatment and HVAC systems, and we must bring to the table engineering commissioning and qualification guides. And these might come from NEB or ASHRAE, US-based organizations, or UK CIBSE or BISRIA, and also industry associations in the life science sector also provide guidance on good engineering practices. So don't forget that element. And of course, GMP qualification. I go back here to Annex 15 of Udrelex Volume 4 as an example, has to be merged in to this sequence if we are delivering a project within a life science good manufacturing practice environment. So the startup setting to work would include testing using the cleanliness attributes in parts 1, 8, 9, 10 and 12, but also might start delivering the monitoring to demonstrate the ongoing performance that's defined in part 2. And part 5, cleanroom operations, specifically identifies elements related to training. So during this startup phase, you should be considering training the personnel who've got to drive the car after you've finished the procurement. And then finally, we come to operations and maintenance, and that's largely covered within part 5 in terms of some guidance on best practices. But remember, in operational maintenance, you will also have application of retesting periodically using the cleanliness attribute standards and the clean room Testing Standards, Part 3. So what I've tried to do is to give you a principle, a concept of how this family of 18 standards, some of them are clearly and absolutely optional depending on your application and the cleanliness attribute needs. But you need to understand which ones you should have in your library and which ones to pick and apply at various stages, and which ones, for example, if you're procuring a design and build service from a cleanroom contractor, which standards you would expect or require those parties to use on your behalf. And I finally put at the bottom EN 17141 related to microbiological cleanliness of the space, which is clearly another important attribute. Now, I put that at the bottom because I just wanted to highlight this standard does not set any levels of microbial cleanliness. It's much more focused on the practice of developing an environmental monitoring program for microbial cleanliness and the evaluation of data and the development of alerts and actions related to turning that data into management information. So my conclusions. I hope you've been able to see how the ISO Cleanroom Standards, first of all, Part 4 establishes a structure that you could apply to the project, that the standards have been developed so they can be applied in an appropriate way at virtually every stage of the procurement, that you can see how business and regulatory requirements can be meshed into this process, particularly the GMPs in the life science sector. And very importantly, good engineering practices are an essential foundation, and ensuring you have the right parties with the right competencies in support of your investments is really important. So finally, I hope you found that useful. If there are, if you have any interest about the Contamination Control Network, then please look on the website. You'll find all the information you need there. I see there's a nice message from Connor Murray, who I mentioned to you is the convener of the ISO working group that is looking to morph EN 17141 into an ISO standard. So and he would be very happy to hear from anyone who is interested, concerned, or wants to find a way of contributing to that process. So thanks very much for your attention. Can I see then if in the last few minutes there are any questions? So Alan Sweeney, thank you very much for your nice message. Anyone, any specific questions? Okay, Connor Murray has put his email address in the chat. Can you see that? Connor at 3imention.ie. So please email him directly. Anyone else? Okay, question about the contribution, the presentation. So CCN will make this presentation available. Well, I'm glad somebody found the route map helpful.
Gordon, it's Connor here. I think the way you've showed it and aligned it to the -4 flowchart is really good, because that's how people will use it in practice.
Yeah. Do you want to just say hello to people, Connor, just as you've come on?
Okay, I don't want to steal your thunder.
No, don't, but I just, because I've mentioned you at least twice, that you might just like to say hello.
Yeah, well, welcome everyone. I was the convener of CEN TC 243, Working Group 5, which the Europeans took up back in 2014 because we had some disputes over how to do it originally back in the late noughties, mainly around trying to find classification tables. So what's really interesting in EN 1741 and Annex 1, which it relates to, is that in Annex 1, there are tables of classification, but only for airborne particles. There is a separate table for monitoring of microorganisms, but it's not a table of classification. So there was a lot of confusion in the industry around that. So we're very clear, and that's, as Gordon has said, the EN 17141 is really around the process and the quality risk management, and using this new term CCS, the contamination control strategy that you're employing around the world of microorganisms, which are very hard to see. They're really, really small, and COVID-19 is a salutary lesson in terms of that. A lot of the traditional methods are not real time, they're sampling, they're indirect methods. So there's a big challenge. It's a very big world to deal with. So interesting times.
Thanks, Connor. Can I just deal with in the last few moments, just a little bit?
No, I'm done.
Thank you very much, Connor. A couple of questions. There's a question from Andy Warsick about, in the preamble, I mentioned EN 1822 and ISO 29463. So these are two standards concerning HEPA and ULPA filters in simple terms. We have a slightly strange situation. EN 1822 Part 1 is implemented as an EN, and all its other parts have been replaced by the relevant parts of ISO 29463. ISO 29463 is not, Part 1 is not published as an EN standard, because in Europe we don't like the complexity of the multitude of filter grades that are in the ISO standard. Now, if you understood all that, then good luck. There is a section on that in a small piece in the public domain part of the CCN website, and a detailed expose on the complications of the ISO and CEN HEPA filter standards in the members section. And then there's a question from Tim Ransom, I think. Any idea when new part 4 will be published? The DIS, I think, will appear in the next 3 or 4 months. Connor has updated his email address because he can't spell. Thank you, Connor. Anyone else, any final questions before I close the session? Okay, well, I just thank you all very much for attending. I'm glad that a large number of you who've responded have found it useful. If you have any questions, then please feel free to direct those back via CCN. And I look forward to seeing some or all of you at occasions in the future. Thank you so much, and take care and stay safe.